guys, this is my first video. So today we're going to do a mock interview of a quant post at some of the big firms. So you will mainly need these courses to follow along and understand what I'm saying, and also I guess try and do the problems yourself at home, and I'm just here to show you what's right, what's wrong, what you should be doing, what you shouldn't be doing in an interview, and get all your chances up to try and get that role. Let's get started. Perfect, so first question, x to the power of x to the power of x, keep going, is equal to 2. So what is x? So basically we're going to start off with doing limit, and the notation I'm using is x to the power of x to the power of x, and this limit is equal to 2. Then, knowing that we have n times x to the power of x, we can rewrite this as x to the power of x in brackets, continuing, equal to, and here we have n minus 1 times. Basically we just take out the first one, and we know when n goes to infinity, it doesn't matter if there's an extra x to the power of something, because it's anyway going to go to infinity. So we can rewrite that straight away as 2. So here we have literally x to the power of 2 is equals to 2. So x is square root of 2. We take only the positive part, because no negative number is going to be equal to 2. So first answer is done. Perfect. So the next question is a little bit more complicated. So suppose value of the road. So here, basically, what you always want to do in an interview is define what's x. So x, I'm going to define it as the minimum of the 3 die. And we can start straight away with the definition of the expected value. So it's a sum from the minimum, which is 1 to 100, of p of x greater than k. So that's basically what we're working with. So now we will have to think a bit, so what is the probability that x is at least k? So if we think about it, it's 100 minus k plus 1 divided by 100. So if we try with k equals 100, it's right. And if you try with 1, it's also right. So in both definitions, we have either 100, either 1, which shows up. So but this is for 1 die, so we have to put it with the cube bit. So basically we have all 3 die, they all follow the same rules independently. We can rewrite e of x, which is 100 cubed over 100 cubed plus 99 cubed over 100 cubed, and we go on to the last term. Perfect. We can rewrite this and put 1 over 100 cubed in evidence, which is 100 cubed plus 99 cubed plus 21 cubed. Basically now, the only thing is, in these kind of quant interviews, they aren't allowed to use a calculator, so you're basically going to use little tips and tricks that you learn when you go through the exercises. So here, the little trick is that the sum of I cube is equal to the sum of I squared. So basically this you can rewrite as 1 plus 2 plus till 100 squared over 100 cubed. The sum 1 to 100 you should know, it's 5050 squared over 100 cubed, and often you aren't allowed to calculate, so you can estimate at about 25 using this take 5000, take 100 cubed, and all the zeros simplify to about 25. So for this next question, we're going to go through a bit of a harder question. It's more probability, which is very important. So we assume that we have x1 till xn, which are independent, identically spread random variables between 0 and 1. Random variables between 0 and 1, which is logical. So what is the probability that Sn is smaller or equal than 1? So the sum of every x1 till n is smaller or equal to 1. So often what we want to do in these type of questions is go case by case. So let's start with n equals 1. We have x1 equal 1, so literally the probability of S1 is just going to be 1, because you only have one element. For n it equals 2, so n equals 2, it's going to be x1 plus x2 equals 0, so, no, excuse me, smaller equal than 1, which is just a line in the plane which stops at 1, 1, so it's a square, sorry for the bad drawing. And the area is just going to be 1/2, so S2, 1/2, probability is 1/2. For n equals 3, the third case, it's going to be x1 plus x2 plus x3 smaller or equal to 1. So this is going to be a bit of a weird shape, I won't draw it. But it's going to be a tetrahedron, which is a funny shape, and the area is going to equal 1/6. So I guess that's general knowledge. So that's going to be the probability is then going to be equal to 1/6. So now we have a pattern that we can clearly see. The pattern is that it's n factorial. So p of Sn is equal to 1 equals 1 over n factorial. So technically you finished the question. I mean, you've shown that it's 1 over n factorial, but again, you're only showing for 3 cases. So now the interviewer is often going to say, please continue, and can you prove that statement? So what you're going to do is you're going to go by the definition. So this is what you want to prove, plus 1 factorial. So by definition, you can write that it's equal to the integral 0 to 1 of f of x n plus 1 times the probability of Sn smaller 1 minus xn plus 1 d xn plus 1. And from here you can continue that the f of xn plus 1 equals 1, the probability of the density function. So now we need to try and search what is p of Sn smaller than 1 minus xn plus 1. And that, we're just going to shrink every dimension of the nth dimensional simplex. So basically, it's a lot of talking for just actually replacing 1 by 1 minus xn plus 1. So basically, it's just going to be 1 minus xn plus 1 to the power of n over n factorial. So we just replaced 1 by our term here. And now we can integrate straight away because we have the term. So it's going to be p of Sn so equal 1 is equal to the integral between 0 and 1 of 1 minus xn plus 1 to the power of n divided by n factorial of d of xn plus 1, which is just a pretty easy integral. 1 over n factorial, 1 over n plus 1, which is just 1 over n plus 1 factorial. So we've shown that it works also for n plus 1. So our proof is finished. It does work. So we proved that for 1, 2, 3 it works, n plus 1 it works, so it works for every number. So our proof is finished and the question is finished. So for the final problem, I've designed one that's very important, that's a bit more complicated. It's different from the last two, it's a more coding question. And basically I've already written out the statement, so I don't have to write it all out. So suppose you have a one-dimensional array A with length n that contains both positive and negative numbers. can you please design an algorithm to find the max sum of a contiguous subarray Aij such that V is really defined as the sum of the subarray. So basically, for this problem, you can start off with an O(n squared) algorithm, and you can tell the interviewer that you know that you can do it O(n squared) with brute force, which is basically you do the sum of all the subarrays, and you find basically you do 1, 2, 1, 3, 1, 4, and even more, and basically you want to find the max pretty easily, but the problem is it takes a lot of time. So you can actually find it, the solution O(n), and the answer in O(n) is basically you define a function t, which is a sum from 1 to I of a of x, and you're going to define v of ij as the difference of t of j minus t of I minus 1, and basically you want v max, so you want to maximize v. So to maximize v, you want to minimize t of I minus 1, so that's t of j minus t, the minimum, which is just the min of t1 till tj minus 1. And then they often ask to write some code, which I'm not going to do. I'm going to write the pseudo code, which is t. So let's start. Basically, this is like simplified code, which is very easily transposable into C++. A minus 1, we have t min is min of 0t, and then you basically want to do for j2 to n, you have t plus a of j, and basically you have if t minus t min is bigger than v max, then you give the value of v max to t minus t min, and if t is smaller than t min, then you want to give t min the value of t, and then you want to return v max, and you've finished. So basically that's the pseudocode. You can write it in C++, but I just can't be bothered. So that's it for the last question. So basically that's done now. I've presented 4 questions. First one was pretty easy. The 2 and 3 were not too bad, but not as complicated as an interview. I guess interview questions, already there's more than 4, and often they rank up pretty fast. So when you get the easy ones done, you go to some pretty complicated questions, but at the end of the day, you aren't going to be able to solve all the questions. You just need to show your workings out, show that you're capable of going far, and really also don't give up, don't say I don't know, always ask hints, because it's what they're there for. They want to test your ability. Also, they know that you're human, you stress out and all of that. That done, I want to offer you guys a few questions like right now on the screen. So basically these problems I recommend doing, they're pretty fun. The first one is pretty complicated, I'd say it's harder than any of the ones we've done in this video. And please leave any questions / comments on anything I can do better in the comments. Thank you very much guys for listening, and see you soon.